Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Cindy.
And in studio with us we have Maddox. And Maddox, if somebody needed to get a hold of us, what would they need to do?
For math homework, help, call in Bakersfield 636-4357, toll free 1-866-636-6284, email dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So where do you go to school and what grade are you in?
I go to school at Laurel Glen Elementary and I am in 5th grade.
How's that going so far this year?
Pretty good. It's kind of hard with the social distancing, but I think it's going pretty good.
Okay. What do you find anything kind of easier using the computer all day or not?
I mean, probably if we're doing a lot more on the computer, right? So, and we still did quite a bit of stuff on the computer whenever we were in online. I mean, not online.
But you were
regular.
at school.
Yeah. So I guess the stuff we did online already is easier, but really anything else isn't.
Well, you're getting good practice at it now, right? I
Yeah.
mean, doing it every day, you're online all day, being able to work a way around a computer and learn more about it is one advantage of doing it this way, right?
Yeah.
Learning how to get on meetings, right? All of those different things, right? So all those things are going to continue to be part of our lives. Hopefully not as much as they are right now as far as school goes and things like that. Anyway, we do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, so today's Math in the News has to deal with, so Maddox, do you know anything about the stock market, or have you ever heard of GameStop?
I've heard of GameStop, but I don't really know anything about the stock.
Okay, what do you know about GameStop? Like, what is it, or anything you know about it?
They sell a lot of gaming things, a lot of different collectibles and gaming consoles.
All right, so you're familiar with GameStop, that kind of a store, right?
Yeah.
Are you into gaming and doing that kind of stuff a bit?
Yeah.
What kind of stuff? I mean, are there any games that you make sure I always play, are ones you like or you do well at?
I like Minecraft a lot. I do pretty good in that one. That's probably the main one.
Okay, so Minecraft is a big one. Do you do Roblox?
Not really, no.
Do you know about that? I mean, is that like a new thing, or is it just kind of like Minecraft, or is it different? I don't even know.
It's pretty old. It's but it's popular. It's a game where there's a bunch of different games inside that one game. Like a bunch of different people can make things and put them on to the. It's kind of like a website, and there's a ton of games on there that you can play.
Okay. Well, GameStop was pretty big news the last week or so as far as the stock market is concerned. And we can see a couple of different graphs right here. Here we can see one, graph is kind of steady and then boom, shoots right through the logo. But let's take a closer look at this. So we can see that since 2021 began, GameStop is up, it was, over 1,000%. Okay? Now, usually if somebody buys a stock, and if they make 20% over a period of time, they're doing pretty well, right? It's like, hey, I made 20%, I made some nice money. on this stock investment, because if you go to the bank and you put $100 in the bank, at the end of the year you might have $102 or something, right? Because the interest rate isn't very high right now, okay? So along with it comes risk though, right? Because you don't know if the stock is going to keep going up or if it's going to come down, okay? So here we can see the percent change since last year during the summer. So you can see it was way down here, right? And then September started to gain a little momentum, 348% over that time. Here, this is a monthly one, once again since September. So you can see that at one point during one day, it was worth $347. So I want you to just round that. So just think $350, all right? Now, in one day, it made $200. So what was it before that? It's now worth $350, and it made $200. So what would it have been before that?
So we're rounding, right?
Yep.
So it was at.
You want to write on the board? You can.
Oh yeah.
Okay. So you can just write right on top of any one of those. It doesn't matter. So it's worth $350. Oop, maybe not. We'll try it again. There you go. And it went up by $200. So I want to know what it was worth yesterday. So the $200, am I going to add it or subtract it?
Subtract it.
There you go. So subtract $200 from that.
You want me to like?
Yep, you write it right on there. So subtract 200 from that. So you're going to go 350 minus 200.
Okay. $150. That's
Right. So it was worth $150 yesterday, right? So that's why they're saying it went up over 100%, right? Because if it was worth $150 and it went up another $150, you would have made 100% of your money. But here, we made more than that, which is why the percent is over 100. Does that kind of make sense?
a little bit. I think.
Well, that's fine. You know, I mean, we're just getting into this a little bit, right? So I figured let's go ahead and take a look at how people can buy stocks if you don't want to buy, because some people go, well, I have a little bit of money, but I don't want to buy something expensive. So you can buy part of a share of stock. So here's an example. Have you heard of any of these companies up on the top?
I have heard of all of them.
You've heard of all of them? Mm-hmm. Well, pretty good marketing on their part then. This one, easy enough to know. Best Buy, it says it, right?
Yeah.
What's the one in the middle?
That's Apple,
What's this one?
Nike.
All right, which one do you want to work with?
Let's go with Nike.
Let's go with Nike. All right, so I'm going to give you a calculator.
Okay.
All right. So the person sees that Nike is worth $120.
Okay.
All right. So somebody says, if you want to be in Nike, you have to give us $120 and you have one full share of Nike. Okay.
Okay.
That means you're part of the company. Somebody goes, yeah, I want to be part of Nike, but I don't have $120. I just have $5. So you can do that. That's a fractional part, right? If something is a fraction, it's a part of something, right? Mm-hmm. Like if you have 1/2, you don't have the whole thing, do you?
No.
You have a part, okay? So in the calculator, what I'd like you to do is put 5,
Okay.
and we're going to divide
All right.
120.
120.
And what does that equal? So you're going to hit equal or enter? Or did I give it to you already?
What?
Yep, so okay. So what does that say right now?
0.0416666667.
Yeah, a lot of sixes in there, right? Because it's going to be a repeating decimal, okay? Now, how do you think we're going to get to a percent? Do you know what percent means?
Yeah.
What does it mean?
It's like percentage. It's like how much you have, I think.
Okay, out of how much? Like if you get an 80% on your test, you got an 80 out of what?
100.
There you go. So it's 100, right? So hit times 100. And what do we have now?
4.166666667.
All right, so it's 4.16. Let's stop there.
Okay.
All right. Now, how do you think they got 4.2? Because you just said 4.16. So how do you think they got to 4.2 instead of 0.1? So look on what you've got. So you've got the 4, right?
Yeah.
And then it's at 0.16. But here it says 0.2. So do you know about rounding?
Yeah.
Okay. So what does the number have to be to round up?
5 or up.
Okay. And do we have a 5 or higher in there?
Yes, the 6.
The 6, right? So that's why they're saying 4.16 is going to turn into 4.2%. So if you have $5, you would have 4.2% of a share of Nike.
Okay.
Kind of makes sense a little bit?
Yeah, I think so.
All right. If you wanted a whole share, you go, I don't want just 4%, I want a whole share. How much is that going to cost you?
$120.
$120, right? So there you go. So you've got the difference between a whole share and a fractional part of share, and that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 this afternoon, but right now we have an opportunity to head out and about and continue our series from seed to harvest.
Hey, a little math in the real world, everyone's favorite part of the program where we get a chance to show you how math really is happening in real life. Still continuing our series on seed to harvest. And I'll tell you what, this is my friend Jeff Rasmussen. We've seen him before, agronomist. He is the expert that I have come to make sure I can learn how to do stuff. Jeff, I'm ready to plant. You got some plants, you got a shovel, we got some ground. Let's put them in the ground. Let's do this.
You
Yes,
ready?
I'm ready.
Okay, you ready?
Yep.
Not yet.
Not yet. We have
Again,
more to do.
We got more work to do. We're not. We're
There's
close.
always something.
We're close.
All right.
So you just want to dig in this ground, and so this is good. But in farming, we succeed to greatness.
Right.
Okay. So what happens right now, if we planted right now, and we pulled these rows, but before we pulled the rows, we had to put the elements in the soil, like gypsum and compost, and more organic fertilizer in this ground.
Right.
And we mix that all in there, right? Make it a nice bed, like the bed you'd like to sleep in, nice and perfect, right?
Yeah.
So right now you can see these clods aren't perfect. And so if we plant this transplant in here, okay, you can see it won't go in there very nice. And so it's going to dry out. So what someone did, an engineer, said, hey, what if we made this machine and mulched it and did all this and put the tines this way, and we knew the PTO of the tractor could spin this much, and we could do this. Again, some engineer, very smart, said, let's mulch it.
Yeah.
And so right now, you can see some of these beds are already done, and this one's not. We're holding out because if we did it now, it could dry out. So right now, this bed that has been mulched hasn't been done. So we're close. So we're gonna look right now at the machine and how the tines work right behind us.
Yeah.
And so the tractor turns the tines and it makes the bed seed ready. So it goes right here, and inside there's a bunch of tines in there that mulches it, okay? And then this right here, someone said, hey, let's bend the bed, the metal, to shape the bed. And if we get on the other side of the tractor, you'll see what it looks like once this mulcher has gone through the field, okay? So that bed now.
This looks a lot more inviting. If I was going to lay down, I don't want to lay down on those rocks. I want to get in a nice flat bed.
So now it's ready to go. So it's nice and mulched. Okay, this bed, it's called seed ready to put seeds in here. But we're using transplants.
Right.
Okay. Now we're getting close to start planting. Let's go check out the planter.
Okay, let's check it out.
Good. So we'll check back with these guys in a little bit and see how everything is progressing from seed to harvest. In studio with us, we have Maddox, a 5th grade student from Laurel Glen Elementary School. And those are Scots, correct?
Yes.
How long have you been a Scot?
6 years if you include, it's called pre-K.
Okay, so you did TK, pre-K or whatever, then kindergarten and all the way through? Mm-hmm. All right, good. So you've been a Scot for a long time.
Yeah.
So you'll be there next year for 6th grade.
Yes.
What do you think is one thing you'll miss? Because you've been there for a long time. when you go to junior high? What's one thing you think you'll miss about Laurel Glen?
I really like the whole layout of the school. I really like, and I also like the huge like yard out in the back, because in the back of the school there's like basically where you go, and it's huge. It's just really big.
Well, good. Well, that's one good thing to have, because there's a lot of schools that do not have a lot of area for kids to go play and run around and stuff like that. So, now we were speaking earlier that you have not used a Venn diagram before.
No.
All right. So you and Cindy are going to work on a problem right now where you're going to use a Venn diagram. All right. So if you want to head over to the board, we'll take a look at the problem together, and then you guys can go ahead and start working on it. So this is favorite colors of a group of students. So we know that 19 like green, 11 like blue, 16 like red, 7 like red and blue, 4 like green and red, 5 like green and blue, 4 like all 3 colors, and 5 don't like any color. The question is, how many students are there in the group? So between you and Cindy, you guys are going to have to figure that out. All right?
Okay. But you're going to have, okay, I can't see.
So I'll read them off to you. All right? So 19 like green.
Okay, so where do you think we should put the 19? By looking at the Venn diagram that's up there.
Off to the side?
So if they like green,
Oh, yeah. Sorry.
no, you're good. Where do you, so, okay, so where would you put it then? If you know they like green.
19 in the green?
Okay, and we're assuming the 19 is just green, right?
Just green. So
Okay,
it's 19
yes.
like green.
So 19 inside the green, yeah. You can just write the number 19.
Okay.
Oh, yeah. That'll take it was a good idea, though.
That's a P. Sorry.
You're okay.
All right. The next one is 11 like blue.
Okay. All right.
16 like red. 7 like red and blue.
Okay, so now where do you think that should go?
Right here?
Okay, good, because that's where red and blue share a part, right?
4 like green and red.
Would that go right here?
Yep.
4?
Yes.
Yes, 4. All right. 5 like green and blue. I'm just going to click out here real quick and see if we can get rid of that. I don't want to delete it. There we go. All right. So 4 like all 3 colors. And 5 don't like any color. So there's it. Where do you think the 5's going to go?
Off to the side?
Yeah, it's up to you and
Can't
Cindy.
go
Where you
inside
want to put
any
it.
of
Off to the
those
side
circles,
will
so
work.
yeah, off to the side sounds good.
All right, now the question is, how many students are there? So, you guys figure out how you want to solve this problem.
So what do you think?
Just add them all up.
Okay, you got a method to how to add them easily?
A lot of things I do is I'll just add like different numbers, and then I'll add up all those numbers
That's a good idea. If you see like easy numbers like multiples of 10 or something like that.
Yep.
Yeah.
11 plus 5, 16. So
You might want to like maybe,
erase them.
or just put a little check mark by it or something, just so you don't reuse a number.
7 plus 4 is 11. 19 plus 4 is 23. 4 plus 4.
Now, hang on. So I think you used.
I think, yeah.
Yeah, you used 7 and 4 here when you added and got 11.
Sorry about
And then
that.
you did 19 and 4 when you got 23.
Thank you. Sorry about that.
That's okay.
And then 16. So let's just add the 16 to this other 16, which is 32. So then I'd probably add 32 with 23. So 2 times 3, 2 plus 3, sorry. 5, 3 plus 2 is 5. So that's right there is 55 plus 11. That is 66.
And then don't forget the one that was left outside there.
Oh, yeah. Sorry about that. The 5. That is 71.
So do you agree with that, Cindy? There's 71 kids in that class?
That sounds way too high. That's why I was like, okay. So that's why I said at the 19, they only like green? Or are we including, for example, you know, this 4 is part of the 19?
Right.
Is that kind of what we're thinking?
Right.
Okay. That clarifies. All right, so the total for green is 19, but that's including these ones that also like other colors. So what we need to do is lower this 19 to how many just like green only.
Okay.
Do you get what I'm saying? So 19 like green, but that's including 4, 4, and 5.
Okay.
So how many would be only liking green?
19. Because 19 is the ones that.
Well, okay, so that's why I was asking the clarifying question. So the 19 is the total number of people that said green, whether they also said other colors or not.
Right, because if you like green and blue, you
You're
like green.
still in the green, but you're also in the green and blue. Does that make sense?
Yeah, so we would also add these?
So we need to take the 5 people and the 4 and the 4, the ones that overlap, we need to subtract them from the 19 to see how many people said green only.
Okay.
Does that kind of make sense?
Yeah, I didn't know it included.
Yeah, no, I wasn't sure. That's why I was wondering the clarifying question. Okay, so let's redo it with that. Because 70, yeah, we definitely don't want classes with 71 kids. Okay.
Oops. I'll just erase it.
Or you can even go to the other side if you just want to
Yeah.
do it on the other side. Okay, so right now we could go ahead and we could add 5, 4, and 4, the ones that overlap in the middle, and then just subtract that from the 19 to see how many people are just liking 19.
Okay, so 4 plus 4 is 8 plus 5, that is 13. So 13 minus 19, let's do that right here. Nine take away 3 is 6. 1 take away 1 is 0. So our answer is 6.
Okay, so 6 people like green only, plus the others that are in the overlap section. So maybe let's, okay, so we're not going to necessarily add the 19 because we changed it and figured out that 6 was the amount that only liked green, right? Okay, now what about the 16 people that said red? What does that also include that we should subtract out?
2 4s and a 7. So 4 plus 4 is 8, plus 7 is 15. So 15 take away 16 is 1 left over.
Okay, so we'd have one person. So maybe write that down near the 6 or something so we don't forget it, just so we know. Okay, and then for the blue, how many people just like blue only? What would you do there?
The 5, the 4, the 7.
Okay.
So let's add that. 5 plus 4 is 9, plus 7 is 16. So
But the 4, okay, so yeah, I lost track of where you guys were, because the 4 is going to be involved in everything. That center one.
No, yeah. How's the 11 work here?
That's what we're going to have you guys work on. So this is not an easy problem. So keep looking, right?
Okay.
And I will keep thinking also.
Because if the 11's including 5, 4, and 7, that doesn't make sense. That's why I wondered if it was just blue or like include, I don't know.
Well, let's look at the clues we've got again. So it's got 11 like blue.
Okay.
All right. So we'll take a look. I'm sure we've got all the information up there correct. All right. So what we're going to do is we're going to work on this like a Venn diagram has the 3 circles. The 3 of us are going to work on this together. But while we're working on that, we do have an opportunity, because doing a lot of work can make you hungry, can't it? Mm-hmm. Well, you know what? We're going to award you with a dinner courtesy of our friends at Grillin' Burger. So there you go on that. Hopefully you have an opportunity to go to Grillin' Burger and check that out sometime. Get a meal of your choice, anything at all that you like. And while we work on the problem, we're going to head back out to see Scott and see what Scott and Jeff are up to now, since I got everything kind of going over there now.
Jeff, we're ready to plant. I'm so excited. Looks like they already got it going on. This is a nice bed.
You ready?
I'm ready.
You
Let's
can't
do
go
it.
planting like this. Come on now.
Gonna roll the sleeves.
We're gonna roll the sleeves,
Here we go.
right?
Let's get into it.
You ready?
Man. Yep.
Are you excited?
I am excited.
Okay,
'cause I
so
see
it's been a
lot of
long
action going
time
on here.
before we even plant. You're ready.
Right.
But you know what?
Is there
Scott,
more to do?
Nope. We got really smart people. We don't have to
Okay.
get dirty.
Oh,
Okay?
nice.
So we're gonna look at this planter up ahead, okay?
Okay, yeah.
Well, let's go catch this planter and look at it. The planting method here. So if you look at this planter, there's a lot going on here. Oh, you want to wait?
That's good. Tell us what's going on here. There's a lot of moving
Okay,
parts.
so there's a huge moving parts right here. So some guy said, hey, let's do this mechanically. And the farmer said, how? So this is what we're gonna do. We're gonna have a planter going this and doing that. The guy says, no way. And he says, yes way, I can do it because I'm an engineer. So as you can see right here, we have this carousel going around and round, okay? That's gonna drop into these chutes on either side of the planter. And you can see it goes to either side. Okay, so now we're planting, it's an alternating, if you can see the plants, they're alternating, okay? So this plant right here got skipped, so behind us, they'll come in and plant that by hand. So hopefully we can alternate these plants to this planter bed right here. So they'll come back and plant that one. So that way we maximize all the planting. So you see the space, it's even. So right there's one, okay? There's one. So you gotta figure that this plant is going to get about 10 inches big, and this one's going to get 10 inches big, and so this one's going to get 10 inches big. So we have to figure out how to plant this stuff uniformly. So, but you notice on the seed bed it's nice and fluffy, and then these wheels right here pack that seedling in there, okay? So it gets a little clogged, so we put these cleats on here to knock off the clods.
The whole entire thing is engineered to make this as efficient as possible.
Yeah, and so you got 4 workers here, okay, working that are planting and putting the carousels, and we're constantly moving the plants. Now in the front of this, and you guys can't smell it at home, there's a strong pungent odor. It's like something just punched you in the mouth.
I will attest to that.
Okay, and so that's the organic fertilizer, okay, and that's from fish, okay. It's not pretty, and we take fish and we grind them up, and that's where we get fish meal and all that fun for fertilizer.
You learned it all from the Pilgrims, right? Didn't they plant fish with their corn?
So you can see the water, it goes underneath. I know we can't see it really well, but in front of that planter, here, there's a shoe that makes a hole, okay? It's a perfect hole. And that plant is dropped in that chute, okay, on this side. And it opens the ground up, okay? And it opens up right here. I don't know if you can see that right there. Okay? It's digging a hole like this right here. It digs a hole. The plant drops down there, and you can see the spring activity. See the spring right here? That's what's putting the seedling in the ground right there. That up and down. And so the engineer figured it on the speed of the tractor and how far to plant this. And so we can change this planting right here. So there's a lot of going on. It's not so much physical as we had to do this by hand. Again, an engineer did that.
Thank you, engineering. We appreciate it. Not that we don't like getting our hands dirty, but wow, this is so efficient. And all of those plants we planted today, basically on this row, because you can put them exactly where they need to be, and then you have people following up behind to make sure that it really was done right. Gosh, still learning a ton. I'm sure there's more to learn about planting. I know I don't know it all, man, but we have our friend Jeff here to help us out. Back to the studio to do some more math problems in the meantime.
All right, thanks for that, Scott. Thank you also to Jeff and the Kern County Farm Bureau, going from seed to harvest. In studio, we have Maddox. We have got a great problem we're working on, but we're not going to let you only work on one problem the entire day, young man. All right? Because you, in 5th grade, have done a little bit with decimals, fractions, and percents. And you kind of know a little bit about order of operations, because you're going to start doing expressions and equations in 5th and 6th and 7th and 8th and 9th and 10th grade, right? So let's start off with a little bit of order of operations, all right? So how about if you go over to the board and write this down. Start with a 3, and then start a parentheses. So next to the 3, open it, there you go.
Whoops.
And inside of that, so start with 2 plus 4, close the parentheses, put a square, a 2 up above the parentheses, an exponent. Now put minus 4. All right, yeah, just erase that and try it again. There you go. And then plus, and what number would you like to add to that?
5.
All right, so put plus 5, and then times 3. So now Cindy is going to go along with you and do this problem using the order of operations. All right?
Okay, so tell me what you know about the order of operations so far.
Really all I know is you have to do the parentheses first,
Okay.
and then you would move on.
Okay, so go ahead and do that step. Solve inside the parentheses.
2 plus 4 is 6.
Okay. And then since you got 6, put the squared on that 6. So the little 2, the exponent.
Oh, I'm sorry, what was that?
Put the 2 right there.
Okay.
And then bring the 3 down. Go ahead and bring everything else down. Do you know what the 3 right against the parentheses mean?
No, actually.
Okay, so whenever a number is up against a parenthesis like that, it's a multiplication. So when you bring the 3 down, you want to put a multiplication in between it and the 6.
Okay.
There you go. And then just bring the rest of that problem down behind or on the right side of the 6.
Whoops.
And then put the minus in front of the 4 for the subtraction.
Yep,
There we go.
thank you.
Okay, so you got your parentheses. Do you know what comes next?
Do we multiply this?
Not quite yet. Have you learned about exponents yet?
No.
No. Okay. So this 2 that's here is called an exponent. And what it means is the number that's the base, which would be 6 in this case, you multiply it by itself however many times the exponent is. So it means 6 times 6 in this case, 2 6s.
Okay.
And that comes after parentheses. So you want to do 6 times 6 right now.
Bring it down.
Well, what does it equal? But bring it down, yeah. So what does 6 times 6 equal?
32.
Check it. 6 times 6? You're thinking 4 times 8.
Oh.
There we go. Okay, so then go ahead and bring down the rest of the problem. So 3 times, and then minus, just bring the rest of that stuff down. Okay, so you did your parentheses and you did your exponent. So now's where you're going to do multiplication.
Okay. So 3 times 36.
If you need to, you can, go off to the side and figure out what that is.
Um, 108.
Okay, so go ahead and write that
Down?
Yeah, just, like you did up there, just like bring it down. 108. And then the rest of the problem, that's on the right side of it. So you already used the 3 though, so the 3's gone. Because it was part of how you got the 108. Okay, now do you see any other multiplications that you need to do?
5 times 3.
So you should go ahead and erase that. Oh, never mind, he gave you some room. Okay, so go ahead and
I moved it for you.
go ahead and solve the 5 times 3 part. All right. And then your last step in order of operations is addition or subtraction from left to right.
Okay. 108 take away 4 is 104. So 104 plus 15 is 119.
Good. There you go, nice job.
All right, so that's a little bit about order of operations, and you had a little bit of everything in there, right? Because we start with parentheses, right? You had to deal with that. Exponents, you learned about exponent. We're going to do, you know what, we're going to do a little bit. Let's do right now, quickly, erase the whole thing. Do you remember how to erase all of that?
Yeah.
What I'd like you to do is, Cindy, go ahead and write 2 cubed.
Well, it's not coming up.
We almost had it there, huh?
There. Well, I see that. There's your
That's
mouth.
mine, yeah.
Yeah. Click on that pencil over there. Does that change anything? Okay, write 2. And then on the top of it, not on top of it, but on the top right, write a little 3. You said cubed, right?
Right.
Okay.
And then next to it, let it go below it.
Below.
I want you to write 3 to the second power. So put a 2 up on top of the 3 like you did the other way. Now, what I'd like you to do is you and Cindy talk about what those actually mean. Okay?
Okay, so you heard what the one in the problem you were just doing meant, right? It was 6 to the second power, which meant 6 times 6. So how can you apply that to what we see here? Got any ideas?
2 times 3.
Okay, so the exponent tells you how many of the number to use, and the base number, the big number, is what you use. So it means you want 3 2s
Okay.
being multiplied together.
So next to 2 to the third power, put an equal sign,
Wait.
the one on top. So
Okay.
put an equal sign right next to it.
Just, yeah, like you're solving a
Okay,
problem.
now put 2 times 2 times 2.
So that's what
Yeah, I
2
think
to
your
the
hand's
third
touching
power
maybe a
means.
little bit.
Yep, sorry about that.
That's fine. Just go ahead and write 2 times 2 times 2.
Okay, so that's what 2 to the third power means. It means 3 2s. All
And what
right?
does that equal?
2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8.
Okay. So let's do the same thing with 3 to the second power. What would that mean? Okay. Nice. Yep.
There you go. That's exactly what I wanted you to do. So once you saw that 2, that's the base number, and the 3, the exponent, means how many times to write it. Okay, so try this. Hot shot. Let's try 4. So go ahead and write a 4. And the exponent, the number you're going to put up on top, will be a 3.
3.
How would we write that? I don't need you to solve it, but how would we write it? Like, put the equal sign. And go ahead and write that out. There you go, nicely done. And then later on you go, 4 times 4 is 16, times 4 is 64, and everything's beautiful after that. But now you've got a little better understanding, just the base of how exponents kind of work a little bit, right? There you go, that's what we want right there. Well, you know what? The Mars rover Perseverance will touch down on the surface of the red planet on Thursday, February 18th around noon Pacific time. Its mission, in part, is to gather soil for testing as scientists search for the answer to the big question, has there ever been life on Mars? Well, Do the Math is counting down to the days, the big STEAM event, with special coverage, with going behind the scenes. And we're going to see how this mission came together and what we can expect from Perseverance once it lands on Mars.
This flyover was produced from NASA images taken from orbit. The blue circle indicates the area the rover will likely land. The arcing hills in the center, about 1,600 feet high and are the rim of Jezero crater. The central goal of Mars 2020 is to learn whether life ever existed on Mars. It's too cold and dry for life to exist on the Martian surface today. But after Jezero crater formed billions of years ago, water filled it to form a deep lake, about the same size as Lake Tahoe. Eventually, as Mars' climate changed, Lake Jezero dried up and surface water disappeared from the planet. An ancient lake is a fantastic place to pursue our goal of looking for possible Martian life. On Earth, lakes are filled with living creatures. Evidence of that life is often preserved in the mud and sand deposited on the bottom of the lake. So, we use the rover's instruments to explore the rocks of the ancient lake bed. Here we can see evidence of the former lake. The canyon cutting through the crater rim was carved by a river. As the water entered the lake, it slowed and dropped the sand and mud it was carrying to form the fan-shaped delta. The white line is a path the rover might follow in its first 2 years, called the prime mission. During this period, we use the rover science instruments to analyze the lake sediments. After we explore the delta, we hope to investigate the shoreline of the former lake. To get there, we have to traverse around a sea of modern sand dunes. From this perspective, you can see former shorelines curving around a headland. We can picture waves in Lake Jezero beating on a sandy beach. And finally, we will press on to the crater rim. Jezero crater formed when a large object collided with Mars, excavating rocks from deep in the Martian crust, exposing them in the rim for us to study. These rocks would have been hot shortly after the impact and may have hosted hot springs. Deposits from these springs would be another target in our search for possible ancient life on Mars.
Well, Perseverance touches down on the Martian surface Thursday, February 18th around noon. Live coverage of the special STEAM event begins at 11:15 a.m. right here on KETN, a service of your Kern County Superintendent of Schools office. And we do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. As a matter of fact, we are going non-stop all the way until we hit April. So in studio with us is Maddox, and you're learning quite a bit today, aren't you?
Yeah.
So I think we're going to get back to the Venn diagram in a little bit. We talked a little bit about exponents, all right? What else did we say we were going to do? We did the order of operations. We did exponents. What have you been working, because in class, you're doing a little bit with fractions, right?
Yeah.
And decimals and percents. Do you know how to turn a number from a fraction to a decimal to a percent?
No.
Oh, there we go. All right. So, Cindy, why don't you think of a fraction that you would like to work with, where you're going to take the fraction, turn it to a decimal, and then turn it to a percent?
Well, since it's just learning, let's start with like common one. Let's do 1/4. So we're going to turn it into a decimal and a percent, right?
Correct.
Okay. All right, so how you turn it into a decimal is with division. So if you had a problem like 8/2, how would you set it up? Which one would you put where? You can just tell me. I'm just trying to get you to lead into the...
8 and 2.
So how would you read this if you see the 8 on top? Do you say 2 divided by 8 or 8 divided by 2?
Oh, 2 divided by 8.
So you read it should be 8 divided by 2. Like if the top number goes inside there. So it'd be like this.
Okay.
Okay. I don't know if you see it like that yet or not, so I'm not sure. So this one, we're going to do this. We're going to divide it. So we're going to put 1 and then 4. All right. Can 1 divide by 4?
Yes. 1 can go into 4.
Not can 1 go into 4. Can 4 go into 1?
Oh, no.
Okay. So this is where the decimal comes in. So you're going to add 0.0. Have you seen that before? Have you done that yet?
Mm.
Okay. So go ahead and start dividing that. So do 10 divided by 8, or 4 goes into 10. Go ahead. You can. I'm just going to put the decimal up there.
4 goes into 10 8 times?
So 8 will be what you get, but 4 times what gives you the 8.
4 times 2.
So you're going to put the 2 on top,
Ahead
above the 0. And then since 4 times 2 is 8, you put the 8 underneath the 10 to subtract it. And then subtract it from 10. Okay, now since you still have a remainder, what you do is you add another 0 right here to bring down here. And then you divide again. So now you do 4 goes into 20.
Four times? 4?
So 4 times 4 is 16, so you're close. So you need a little bit more.
5.
So you put the 5 next to the 2 in your answer up there on the right-hand side. Yeah, above the 0 that you brought down. And then 5 times 4 is 20, so you subtract 20 down there from the 20 that's there.
5.
So you do this, watch, let me see, minus 20. You do 5 times 4 makes 20, so you're going to subtract it. So what are you going to have right there?
0.
So the decimal that's equal to 1/4 is this right here, 0.25 or 0.25, which stands for 25 hundredths if you read it by its place value. Think of 1/4. People often say 1/4 of something. How much is a quarter in money?
25 cents.
There you go, 0.25. Okay, so 25 hundredths. And so to make it a percentage, since we read it as 25 hundredths, and what's percent mean it's out of?
Out of 100,
Okay, so what do you think the percent will be for this?
like leftover.
So if we have 0.25 and we want to make it something out of 100, if it's read as 25 hundredths right now, right? Because that's how you read that decimal. Do you know your tenths, hundredths? Have you learned those place values? Okay. So since we read that as 25 hundredths, it's technically right now 25 out of 100. So what percent would it be?
75.
You're thinking the reverse of it. That's what's left over. It's 25% because it's already just out of 100.
All right.
Because if you write it like this, 25 hundredths, that's out of 100, so that's 25%. You can multiply this by 100 and you'll get this.
All right.
Does that make sense to you?
A bit.
A bit, good. So here's what we're going to do. Leave the 1/4 up there,
Okay,
all right, and erase everything else.
okay.
Now erase the 1 and make it a 2. Now, Maddox, if 1/4 was worth a quarter, what do you think 2/4 is worth?
50.
Right. And how do we write 50 cents? If we were going to use it in money, like with a decimal.
0.
Go ahead and put it up on the board.
Just right here.
Yep. Good. Okay, so you've got the fraction, you turned it into a decimal. Now you want to turn that into a percent. So if you have 2/4, if it's 0.50, 0.50, what percent did you get?
50%.
Write it up on the board. There you go. So does that help a little bit now doing another one?
Yeah, I think
We didn't
so.
have to go through all the division because you knew that 2/4 was 50, right? And it's 50%, okay? Now, how do you think we can get a little higher than 50%? What do you think we'd have to do?
Make that a 3.
Make that a what?
3 or a 4.
Make it a 3, right? Make it a 3. Now, if you had 3/4, 3/4, what decimal would that be? If you're thinking about money again to make it easier.
75.
There you go. And what percent would 0.75 be?
75%.
Well, then put it on the board. There you go, nicely done. So starting with the 1/4 kind of get you a little idea, right? And then you can kind of build on that, all right? Now, here's what we're going to do. We're going to go back and we're going to start working on this problem again, all right? So, we see that green and red are 4, okay? So they can't be included with this and that group, all right? So what I want you to do is, first of all, I want you off on the side, put 19 minus 4. And what does that equal?
Oh,
That's okay.
sorry about that.
You're fine. You're finding new ways to be able to write and move things at the same time. It's pretty cool, all right? So look at what we did, Maddox. We took the green and took away this one with it, all right? So if we're going to keep going this way, what do you want to start with here? We're going to start with 16, and we're going to take away the part that is with blue. So we're going to go 16 minus
7?
7. So do 16 minus 7 off on the side. All right, so now we're going to come down here, right? And we're going to go with 11, and what are we going to take away from the 11?
5?
Okay, so do that on the side. All right. That's different than what I did the first time, I think, but let's see how it works out here. Because we went 19.
Well, we still have the people that didn't like anything.
Right.
And then we still have
yeah,
that
so
middle
let's add
group,
up
that
the
middle
kids
4.
that are in all of them and the kids that don't like anything. Right?
Okay.
So keep going. So you've got the 4 in the middle, right? So just put a 4 out there somewhere. And the 5 is already out there. So take the numbers we have, 15, 4, 5, 9, and 6, and add them all up. So what's 15 and 5?
20?
20. What's 20 plus 4?
24?
And what's 24 plus 6?
30.
30. And what's 30 plus 9?
39.
There you go. So there are 39 kids. What we were doing is we were looking at the kids that were liking both at the same time, and that's what kind of threw us off a little bit. So we'll take a look at that again in a couple of seconds. But right now, we do have another opportunity one more time today to go visit Scott and Jeff and see how everything is going from seed to harvest.
Back to math in the real world, out here in the field. Jeff, we just planted a whole bunch of plants. And as a farmer, which I'm not, but if I was, I'm thinking to myself, okay, got to make sure these are healthy crops, because I just put a lot of effort into getting these things in the ground. We saw an infusion of water when they were planted,
Right.
but now we got to water them throughout the life of the plant, right? And so
Right.
we have lots of mechanisms to do that.
Yes, and water in any crop that we grow here, anywhere in the world, 90% of that crop survival is water.
Okay.
It's based on the water quality, okay, and the amount of water, and how the water is infiltrated, and the delivery systems.
Right. So all those things are super important. Sounds like the number one factor from now till harvest is water. We got to obviously have nutrients. We have to watch out for diseases and all that stuff. We'll talk about that. But water is super important. Now, how do we get the water to the plants? So let's say, we'll talk about the pump in a minute, but let's say the water's already out in the field. What kinds of systems deliver water once you're out in the field?
Well, typically in the vegetable, we have sprinkler systems.
Okay. And that'd be above ground.
Yeah, it'd be above ground,
Right.
and you see the pipes out here today. And we, as we were planting, you kind of saw us dance around those pipes, because once they're done planting, we'll turn the water on. Like you said,
Right.
is they got a little water there. On a day like today, it may get to 75 degrees, so it's not critical. But in the summertime, when we're planting that, there's a lot of stress on the plants. We put the water on to cool them back down.
Okay.
So it's not so much critical that we get it on right away,
Right.
but other years. So the sprinklers is very important, and the water delivery system. So again, another engineer has figured out the materials to use, okay, to carry the pipe, And typically, we've always used aluminum pipe. That's been the standard for many years now.
Right.
And now some of the carrot companies have said, hey, let's go to plastic. Okay. And there's two reasons why we went to two different systems from sprinkler systems above ground. Obviously, you got the different orifices on top that we know the impact sprinklers that some of us have in the yard.
Right.
Okay. And then some of it is more mechanical where there's no impact. It just rotates around. So there's different systems. Now let's still go back to the pipe system. Now, the beauty about aluminum, it's light. We can move it, transport it, it's durable, right? And you have 4-inch pipe and 3-inch pipe, and that was the standard for many years. Problem is it's very rigid.
Right.
And so like the carrot companies got really smart. They said, again, I got an idea. If we could get something that's pliable, we don't have to move the pipe. It's easier on our workers.
Yeah.
Okay, it saves cost.
Sure.
And so what they did is they took a type of plastic, and then so as imagine this, okay? Again, I got this great idea.
Okay.
You're gonna have to move this pipe. So you imagine this hard pipe right here, okay? This is a sprinkler pipe.
Yeah.
So what they did is they made plastic, so instead of moving it, the tractor comes by, has this little shovel, it goes up and over the shovel, right?
Yeah.
And it just bends with the tractor. And so they can cultivate it
Right.
behind as the plants get established, and we go on and take some of the weeds out in the middle of the furrow, and we can open the ground up because the compaction of the water, settles down on the ground and it kind of compacts it, so we want to loosen that up.
Yeah. Yeah.
Okay, so the systems above grounds have changed quite a bit.
So it's always evolving depending on the needs and being more efficient. Really, that's what we want to do, right? We want to be as most efficient as possible.
But wait,
Uh-oh.
there's more.
There's more.
There's more. There's always more. Because we're constantly, that's the beauty about agriculture, is we're kind of nerds, to be honest with you, and that we're always, and that's what a career is about, okay? The career is constantly learning more about what you love doing. And that's that knowledge, right, that gets you going, is how can we do something different? So when we think about that, we said, hey, let's get these plants established, right? And then, I don't know, it's got to be 50 years that we started drip systems and started putting drips underground where we got this plastic and say, hey, what if we put the plastic underneath? We're not wasting water in the air.
Right.
It's not a very efficient system. So we put this system in called a drip system.
Yeah.
Now we use it all over in all commodities, in furrows, in trees and grapes.
And so you're eliminating some of the evaporation, you're eliminating some of the waste, and you're getting the water right to the roots, right where we want it. Man,
But
there's
we're
so
not
much.
there. We're
Oh,
not
there's
done.
so much to talk about.
Yeah.
We have got to come back and talk to you more about water, because we know there's more to talk about. In fact, we're going to talk about some smaller things like you're talking about, but we're also going to go a little bit bigger. So when we return to this series from seed to harvest, we want to know about the big water systems here in Kern County, and we're going to visit with some of our guests. At the moment, back to the studio.
All right, thanks for that, Scott. Also, a lot of things going into that seed to harvest, and we're just at the beginning of this whole thing. We do have phone tutors available until 5:30 this afternoon. Maddox, a 5th grade student from Laurel Glen. Did you have fun today?
Yeah, quite
Did
a
you
bit.
learn a little bit?
Yeah, a lot.
I was going to say, we did a lot of different types of problems today. And you know what? If you ever want to, come back and look at it again. Refresh yourself on that. So, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.